All right, today we're looking at parametric equations. Parametric equations are this concept that we're going to take a normal plane curve, a normal xy, and add in this third variable that we call the parameter. So x would be represented by f of t, some function of t. Y is going to be represented by g of t, a separate function of t. And so at some time t, we're going to get an x value and a y value, and we're going to be plotting them. So the first few problems we're actually going to be plotting x and y using a table of values. So we have t, x, and y, and we'll just plug in some values. So we'll say -2, it's going to be 4 for x and 5 for y. -1, it's going to be -2, sorry, -4 for x. -2 for x and then 2 for y. 0 is going to be 0 and 1. 1 is going to be 2 and 2. 2 is going to be 4 and 5. And we start to see a pattern. And so we'll jump down to the end of this, which is at 4. That's going to be 8 and 17. All right, so this is our table of values. Now we'll actually plot this and see what actually happens. 1, 2, 1, 2, 3, 4, 5. Okay, and so we have our table of values. We have our points. We have -4 up 5, -2 up 2, +4 up 5, and then 8 up 17. We'll call this 8, 17 up here. All right, and so this is our graph. And if we just draw the graph connecting the points, it looks like a parabola. Not a full parabola because we have some limitations to it, but it looks like a parabola. But we also need to indicate the orientation. So we look at the t's and we say, okay, what order were these points plotted? Well, this one was first, and then it follows along the curve leading this way. So we'll have some arrows leading us to each next point. And those arrows indicate a direction that we're going. So each graph is going to have these arrows on it that indicate orientation or direction, and that's what makes these parametric equations so unique, because sometimes you'll have them go the opposite way you were expecting. Like we could have had a parabola that instead went this way along the parabola, right to left, and that seems a little weird at first. Okay, now I do want to talk about this one. I want you to graph it on your own. I'm not going to go through the graph, but if you do it properly, you should end up with an ellipse here. And so we need to talk about how we would eliminate the parameter. So in this one back here, the way we would eliminate the parameter, the way we get rid of it, is we're writing an equation for y equals with x. So we just isolate t, say t is equal to x over 2, and then plug it in. So we end up with x squared over 4 plus 1. Nothing crazy. But for this problem, isolating the parameter is a little weird, because you can't just use arc sine or arc cosine to solve for theta and then plug it in. We know that that wouldn't really work for us because our equation of an ellipse does not look like that. Instead, we have to use the property that cosine squared plus sine squared is going to equal 1. So we can say cosine is equal to x over 2, and sine is equal to y over 3. And so we end up with x squared over 4 plus y squared over 9 is equal to 1. And we end up with the equation of an ellipse there from doing that. Okay? The other thing I want to talk about is the calculator and how will we use the calculator for this. So when we do this and we eliminate the parameter for this one, we just solve for t. We say t is equal to, and if we do it correctly, 1 over x squared minus 1. Then we plug that into y. Y is equal to 1 over x squared minus 1 over, and then 1 over x squared minus 1 plus 1 just leaves us with 1 over x squared. So we get 1 minus x squared. By the looks of this, this looks like a just normal parabola, specifically a parabola that's shifted up 1 and opens downwards. But let's look at the calculator and see what it shows us. So if we go to the calculator, we can change our mode to parametric, and that changes a few things about it. We can now graph a parametric equation. So we have 1 divided by the square root of t plus 1. And then I'll make this one an actual fraction. We have t over t plus 1. Now, the first thing we need to know to change is to change this over here on the left side. Oops. These right here. This lets it change the color, which is nice, but it also changes what type of line we use. And we want to use this one right here, the line with the dot on it. Now, this allows us to easily see the orientation because we can follow the dot along the path it takes. And that's going to show us the orientation of it. The second thing is we need to know the window menu. All of this stuff is important to us, but understanding what Tmin, Tmax, and Tstep mean is most important. The Tmin and Tmax are the smallest and biggest T values the calculator is going to plug in. So right now, the smallest T value it'll plug in is 0. The biggest happens to be 2 pi, because that's just is what it's set to. So it's going to start plugging in 0, and then it's going to count to the next value. How it determines what the next value is the T-step. Bigger T-step means it skips more values before plugging in. So right now, it's going to plug in a T value every 0.13 values. So it's going to plug in 0, going to plug in 0.13, then 0.26, and then so on and so forth, until it gets to the Tmax of 2 pi. And so we're going to be playing with these. So let's start with just as it is, see what happens. Well, if we look at the graph, we didn't even get to see anything. It made this small little segment and then stopped. So let's change our window sum. Let's change our x's and y's. Okay, and let's change our Tmax. Maybe it didn't have enough T values to graph. Let's jump up to 25. Okay, that graphed really fast. We didn't even get to see anything. Let's try again. Oh, it looks like we don't have the dot set anymore. I forgot to hit enter on it. There we go. Now we have it. Let's try again. Okay, we see the dot move some. And so we at least can see the path, but it doesn't look like it's making that full parabola we said earlier. So let's change it again. Let's jump up to something bigger. Let's go something obscene, like 250. Once again, see that same segment, and we see that dot moving, but it just keeps getting closer and closer to that y-axis, but it's never going to actually get there. Okay? We can change it the other direction. We can go, let's make it more negative. Let's go this back to like 100, and we'll make it some negative t's, like -2. Okay, in this one, we now see that it does keep extending along the right side, but it's not ever going to reach that y-axis. So what is actually happening here? Well, if we go back to the equation, we can see this. If we look, our x values, no matter what t we plug in, we are never going to end up getting a negative x value. So really, it's only this equation when x is greater than or equal to 0. And so if we were to draw the graph ourselves, we'd have our parabola, but the arrow would be heading this way along the curve and never actually reaching past this point. They would get close to it, but it would really be an open circle there at that point. Okay, so understanding how the calculator works and what you can get from it is super important. Aside from that, there's nothing else from me. Let me know if you have any questions. You'll have a great